Hello everyone again and welcome to Python tips. So today we'll be looking at list, tuples and dictionaries. So we will start first of all with what we a list. So a list, we can think of a list as a shopping list when when we are going shopping. So in Python, a list is like an ordered mutable. Mutable here simply means we can change items in a list, collection of items. So you can store strings, numbers, or even other list inside a list. So let's take, for example, we saw this yesterday. So a list is mostly created using square bracket. Let's say we have a list of fruits. Um, where we have apples, banana, and cherry, and then we want to perform some operations on that list. There are different things we can do on list. We can try, if we want the first item in that list, we can just do print square bracket of 0 because the first index in the list is at index 0. We have banana should be at index 1, and then cherry should be at index 2. Next operation we can perform in a list is by doing what? Modifying the items in that list. Let's say here we want to change banana to orange. Since banana is at index 1, we can just do fruit, that specific index, and then equals to the string since we want to change banana to orange. So if we do that and print, we can see that in that list initially we had apple, banana, and cherry. We are going to be having now, in place of banana, banana has been replaced with what? Orange. Another operation we can perform on list is adding items on a list. If you want to add items on a list, we do what we do append. Append is like adding items in a list. So if I do list.append, I am going to add um, that fruit grape into that list. So one thing you should note is that the append function in Python always add that the anything you are adding to that list to the last um, uh, should be the last item in that list. So for example, we did append grape, so grape will be added as the last item in the list. So another operation we can do on list is what? Removing items. Let's say we are no longer interested in keeping oranges in that list. We can just do what? Fruits dot remove what? Orange. So if we do fruit dot remove orange, we will now have initially um, we added orange in that list. We appended a grape onto that list. So uh, if we remove orange here, we remove orange and then print that list again. Let's see what we print the fruits again. Let's see what we get. Fruits, and then go back, run it. We see that here we no longer have orange in that list. We only have apple, grape, and grape because we added uh, the another element in that list as a grape. Now, another thing we can do is if we want to know the number of items in a list, we can just do print length of um, that list. So because we have removed, here we had 4 items in the list, but because we remove oranges, we are now having 3 items. That is why when you do length of list, we will be having what? 3. Now we can also do slicing, which is like just getting maybe the first 2 elements in that list. We can just do print. The first index there will be 2, and then because we want just the first 2 elements, we were not going to have what? Apple and what? And grapes. Now, another common thing we call data structure that we will find a lot is what we call list comprehension. We can think about a list comprehension like a list that we are creating inside another list. Uh, so let's start by looking at how we can add maybe items on a list. Now, as I did mention, we start creating a list. We use square bracket. Let's say I want to look through a range of numbers from 0 to 4 because the range is 5. And then I want to add the square of these items onto a list. So I can do for I in range 5, because that list I've created made it to be empty. I can do square dot append I square of what? 2. Remember, this is we did the different kind of operations that we can perform on numbers. We did see how we can square numbers and all the like. So if I print this list, because I've added the square of a range of numbers from 0 to 4 onto this list, if I print it, we are going to be having something like 0, because square of 0 will be 0, square of 1 will be 1, square of 2 will be 4, the square of 3 will be what? 9, and the square of 4 will be what? 16. That is why we are now having here 0, 1, 4, 9, and what? And 16. No, this is one way we can do this. But if we do not want to be going like writing this, which is this line of code is long, we can use what we call what? A list comprehension, which is like creating a list inside another list. So we can just do squares, x squared for x in range what? In range 5. This one, we can see this line of code is pretty shorter than this entire line of code. So, and if we do print square, we are going to have the same output as we had initially. Now, let's take, for example, with list comprehension, we can also want to get maybe even numbers for a range of numbers from 0 to 9. Now, we can use list comprehension to have x for x in range what? 10, if x integer divisor of what? 2 equals 0. So here we are simply saying that we already saw this operator in earlier. So we are simply saying that for a range of numbers from 0 to 9, if the division is, if we divide those numbers by 2 and the remainder is equals to 0, then definitely they are even numbers. So that is why this logic here is giving us what? Is giving us all even numbers that are from what? 0 to 9. Now we can do this another way. If we want to do the case of writing it like just do it in form of a list, we can just create an empty list. Let's call it Alex, and we call that list, let's say, an empty list. And then what we can do, rather than using a list comprehension, we can do for I in range 10. Now we can do Alex dot append, because we are adding items in that list, append I integer division equals to 2, and then we can do what? Let's print, we can print LST and see whether we are going to have the same thing. So it's actually returning us what we have, what? True. Let me see, just hold on. Print I if, let's go back, if, no, I actually get back, let me go back, it doesn't. So we can do if to get that list, if I divide so 2 equals to 0, that if condition, then we are going to do ls dot append lst dot append I, and then let's print it and see what we get. Print. So yeah, so we are having the same thing, the same logic that we had here, getting these even numbers using a list comprehension. Definitely we can do that using what? A list. Now let's go to another data structure type, which we call it what? A tuple. A tuple is a list, but one thing we should note here is that tuples are immutable, meaning that once a tuple is created, as in the case of a list where we were changing and every item in that list, we cannot change items in a tuple. Now, tuples are mostly used maybe to create coordinates, because coordinates, we don't want to change them, we want them fixed. So if we want coordinates, we can do coordinates, print those coordinates. So tuples are mostly created by using what? Instead of using square bracket in terms of list, we are just using what? Our normal bracket to create a tuple. one thing we should note here is that we can also access the same way we access items in a list, we can do same in a tuple. So if I run this line of code, we will have this tuple. If I want this first item in this tuple, I can just index it with what? 0. That's why we are having a 4 here. Now, another common data structure type that we will see a lot even as we move on in key concepts in machine learning is what we call what? A dictionary. Now, a dictionary is what we call a key value pair, meaning that most dictionaries, they have a key and a value attached to it. Now, those keys are mostly used to access those values, and dictionaries are used a lot in most data structures because you only need to access every value in that dictionary by using what? A key. Now, one thing you should note is that they are on order, especially in Python versions that are less than that's 3.5. They are also mutable, and we can also a great way forward for lookups. Let's start by creating a dictionary. Let's say person. A person can have what? A name. So this name here will be what? The key, and then the value there will be what? Will be Alice. A person can also have age, which we can give the value of the age of that person. A person can come from a city. Let's say that person is coming from New York. And if you run this line of code, we are going to see that, the key there, as I said, is name. We have a list and all the like. Now, we can access, like we were doing in the case of a list where we access items in that list by using indexes. In the case of a dictionary, we can easily look up every item in the dictionary by just using what? By just using those keys. Let's take, for example, if I want to access a list, I can just do what? Person, square bracket, name, and then here, I'm having the output here as what? As a list. Now, if I want to add maybe an email, which is like that person's email to that dictionary, the key now will be what? Email, and the value will be what? The email address of that person. Let's say I'm adding that email. So because I created already that dictionary, which is person, I can just do person square bracket email equals to what? That person's email. Now, when we do this, we see that in that dictionary we already have, we are having another key added there, which is email and the email of that person. Now we can also update the age of that person. So to update that age, which is the same like changing the age of that person, we can just go person age equals to what? 31. So we see that when we print out the output, the age of that person, which was 30 initially, becomes what? 31. Now we can delete. If I want to remove a key, I can just do maybe there. Here simply means delete person. Go in there and remove what? The city. Now, initially we had the city of that person to be New York, but with the final output here, what do we have? We do not have that city again and the city name because it has been removed. So please, guys, keep following for more because these data structures are used a lot, whether you are doing text processing, whether you are doing a lot of stuff in machine learning, whether you are going to be doing visualization, you will see a lot of these data structures a lot. Lists, tuples, and dictionaries. Please, guys, also, I will be sending out this notebook in the comment section, both on Facebook and YouTube, because it also has exercises on it. Please try by all possible means to do these exercises because it is a great way to practice whatever thing you've learned. Thank you so much, guys. Keep following for